Hello. So now that we know what IXPs are, what I'm here to tell you is that some IXPs are about to go IPv6 only. This presentation has already been hyped a bit in some earlier presentations, but I've got an admission to make. This presentation is actually not about IPv6 at all. It's about making IPv4 last longer. So RFC 8950 specifies a method of announcing IPv4 routes using IPv6 next hops over BGP. So what this means is that operators can strip their core networks of IPv4 addresses from the link networks and use that space for something more productive. They can have just IPv6 in their backbone, and BGP will take care of IPv4 traffic, basically replacing ARP with IPv6 neighbor discovery to figure out what is the next MAC address that this IPv4 packet needs to go to. And well, you can't take all IPv4 addresses away from the routers, because things like traceroute will stop working because they need to send ICMP errors using some IPv4 address. There is actually an RFC that specifies globally unique source address to be used in cases like this. But it would still be nicer if each router had their own IPv4 address, so that your traceroute would have different reverse mappings along the path, so that you can figure out which cities your traceroute is going through and so on. There are also other uses that might require an IPv4 address on the router, but usually it's enough to have one address that will be used for the remaining needs that the router has for IPv4 addresses. So what's this got to do with IXPs? Because IXPs already have IPv4 addresses, and in Europe, if they don't, RIPE has a policy that makes sure that new IXPs can still get IPv4 addresses. So why am I rocking the boat? I'm rocking the boat because renumbering IXPs is painful. Lynx is one of the older and one of the bigger IXPs, and they renumbered their peering LAN from /22 to /21 in 3 years ago. Are there any people in this room that were connected to Lynx at that time and remember? Okay, so there's at least 1, 2, a few people. Yeah. Was it fun? Liar. How about 2012? Were you connected then? Okay, a few more people were actually connected back then than now. And 97 was the first time they renumbered. Moyaza works for Lynx, and he gave me some of these dates. France IX, as another example, decided to renumber one of their IXs in the winter of 2019. And in 2021, they finally concluded that the renumbering is now complete. So it took over a year to renumber. AM6 renumbered in 2014, the last time. Of course, they had renumbered a few times before that. DGIX actually went a different route. So the first time they had to renumber, what they did was that they chose a network that had a lot of empty space after it. So they renumbered once, and then they changed the net mask to a bigger net mask a few times. But well, I guess there are some DGIX people here, but not sure if they're actually from the networking side, but I can tell you that changing the net mask on an IXP is just as painful as changing the whole address. on the IXP, because if people have different net masks on their routers and they're using the route server, for example, you'll end up black holing the traffic, or the routers will use the routes learned from route servers to forward traffic to the transit or something silly like that. NetNut, which is our closest biggie here in the Nordics and Baltics, have miraculously been able to avoid renumbering completely so far, at least because of running out of IP addresses. They might have renumbered for other reasons. Here is the alternative. When you run out of, when you are running an IXP and you are running out of addresses, you need to ask yourself, how many times do you want to do the renumbering? Or do you switch to IPv6 next hops, and that is the last time you have to think about the number of addresses on the subnets, because they're not going to run out. And the thing here, the word renumbering is in quotes, because it's not really a renumbering, because all members already have an IPv6 address on the IXP. Even the ISPs, even the operators that don't actually have IPv6 traffic, still usually have BGP sessions over IPv6, because some of the big content providers, for example, require that they won't peer with you unless you have a IPv6 session as well. So what it really requires to renumber to IPv6 next hops is that you turn on one more address family on your existing IPv6 peering session, and turn on the feature usually called enhanced next hops, which will do this thing that I'm talking about, RFC 8950. Nix CZ/SK already runs this in production in 3 exchange points, 2 in Prague and 1 in Bratislava, I guess, Slovakia anyway. And they've got a few dozen operators, and I think it's close to 1,000 IPv4 routes that are using this mechanism already. Some of those operators have actually started to turn off their IPv4 BGP sessions in order to promote these IPv6-based BGP sessions for IPv4 traffic. B6 in Berlin and Trex, where I come from, are also gathering experience on this technology on our exchange points. So Trex Tampere is our bigger exchange point, and we have one route server there where we have invited our members to turn up BGP sessions to, first of all, see how their own gear works with it, and hopefully to start the migration toward this mechanism in Tampere. But what about new IXPs? As I mentioned earlier, RIPE has an address space assignment policy specifically for IXPs. But a few years ago, or was it last year, that policy, which used to guarantee a minimum of /24 for IXPs, was changed so that now it guarantees a /26. So to get to the comfortable /24, you'd need to renumber twice. You'd need to go through the hell of renumbering a few times to get to the normal size of an IXP subnet LAN. And so at the bottom I mentioned that Trex set up a new exchange point in Turku, and we had some IPv4 addresses earmarked for it, but then we realized if we started off having IPv4 addresses, it'll be difficult to get the ISPs to hand them back to us. So what we are testing with Turku is what if we plan to never have to renumber at all? in other words, what if that IXP is IPv6 only from the start? So IPv6 traffic will be exchanged completely the same way as before, but all IPv4 traffic will be exchanged using this RFC 8950 mechanism, enhanced next hops. Well, Trex Turku is a very new IXP, so we don't have a lot of members there yet. And we also haven't turned up the second site yet. So it's a work in progress, but maybe I'll come back next year or the year after that and tell a different story about that exchange point. EURIX, I think somebody in some other presentation already mentioned EURIX. So it's an association of European Internet exchange points. And they started a working group a couple of years ago to work out what the challenges of this technology as applied at Internet exchange points are, and what would be the best practices, and also to gather experience about using this at IXPs. Andre Grüneberg and I are chairman of the group, and other active members in the working group are, well, there are a lot of members, but the more active ones are from some of the big exchange points. But also IXPs, who are the makers of Bird routing daemon, which a lot of IXPs use for route servers. NetDef is the organization behind FRR, which is another very common route server routing daemon, and so on. So it's not, the members of the working group are not restricted to the membership of EURIX. So EURIX outsiders can join. We have a GitHub where we document stuff, and so and where we have tons of examples, config examples for different platforms. We've got list of all the platforms and the software versions needed on those platforms that support, or who have specifically said that they do not and maybe will not support, and so on. It's still work in progress. So we, if you want to pitch in, we accept pull requests. We also have a mailing list and a Mattermost chat channel. We have a Zoom call every 6 weeks to, track progress and so on. Now, let's go to the challenges. What are the problems? So originally, actually, this isn't even a new thing. The original RFC was 5549, and it's from 2009. So 8950 is just an update of the old RFC. But the initial implementations and most of the initial use cases for this technology were aimed at MPLS VPNs. So it was operator internal and not public internet routing, but VPN routing. So testing if different implementations work together wasn't really a priority for anyone for a long time, because MPLS VPNs are only usually within one operator, and the one operator typically runs one platform or maybe two platforms, but they make sure that they work together. So when we started to look at how it could be used at IXPs, the first thing we realized is that nobody had tested if it works in a multi-vendor, multi-platform environment. So that is what we've been doing for a couple of years. And I think, well, I have to hand it to DKIX, who I already mentioned once. They actually hired a master's thesis student to write his master's thesis about the interoperability testing. And as part of that work, he did a big interoperability test. He had like a dozen different platforms running in virtual machines. So of course there were the open source platforms, but there were also like Cisco and Microtik and Arista and Nokia, SR Linux and SROS, stuff like that, hardware platforms that actually have support. And then he automated the interoperability testing between each and every one, the huge matrix. So actually at the GitHub is the matrix that he created. One of the issues that still haunts us is that ICMP unreachables can be unpredictable. So typically and this is the address that shows up on a trace route. It typically should be either the address on the interface facing where the traffic is going or where the response is going, but on some platforms it can be some completely different address. Actually, if the interfaces concerned don't have an IP address, it should be a loopback interface, but it can on some platforms still be a random address. So that is weird, but not all platforms suffer from this. Another point is that the best current practice in IBGP has for a long time been to use next hop self. So when a router learns routes from an external resource and announces them over IBGP, it should replace the next hop with its own address. That is what next hop self means. And with if you start using RFC 8950, it becomes more important because otherwise it would be sending IPv6 next hops for IPv4 routes. And what if some other router in your IBGP mesh doesn't support that extension? Then they won't know what to do with that traffic. But if it does next hop self, then it doesn't matter if the other router doesn't support it, because it'll follow the normal next hop to the border router. And I should also mention that in the 2 years we've been working, as we've been sending bug reports and giving feedback to the hardware vendors and software vendors, a lot of the problems we've had have been fixed. A lot of platforms have matured. So actually, I've been giving this presentation this year at 4 other events. The last time I gave it was an event I hosted myself in Tampere in June, and it was actually a different version. It was more about Trex Turku than this technology, but anyway. In that presentation, I mentioned one vendor, actually 2 vendors, where the implementation is almost there, but not quite. And before the event ended, I had 3 emails in my mailbox from that vendor, their support. They had opened a ticket to fix the issue I complained about, and now their platform works perfectly when before it didn't have the support at all. So that is a nice feather in my cap, maybe. Yeah. I still have a couple of slides, but at this point, before I go to those slides, I'd like to ask if you have any questions, because we have a couple of minutes, and if there are questions, I'd rather use those on the questions than on my remaining slides.
Okay, just raise your hands as always. 2 minutes left for your questions, or maybe some comments, insights. Something maybe? Oh, okay. I can see the hand in the front.
Hi, I'm Mara. I couldn't resist, sorry. So I noticed when you said you're going to do the renumbering, do IPv6 only, the exchange, I'm sorry, I don't want to offend anybody. It's not a big exchange, right? How many members do you expect? Below 50, right?
Yeah, Finland is a small country, below 50.
Yeah.
Yes.
So it's actually a very good way to test things, and if they break, right? So is this somehow a first step that you're going to prove that if it works, even bigger exchanges might be able to, apply this as well?
Well, NIC-CZ has this Phoenix subnet, which is sort of the higher security conscious ISPs. And they already are much further along than I am. They started after me, but they have gotten already further than me. So I salute them. I think, and Nick sees that it's not a small IXP.
I agree. Yeah. For sure, it's already a step forward. Yeah. Thank you.
And also DKIX and all the very big guys are also actively researching. They don't have any plans to adopt it yet, but they it could just suddenly happen overnight with them as well.
Thanks. So basically, if you prove them that it works, they will apply it.
Maybe.
Just like IPv6, right?
Yeah, I can't make promises on somebody else's behalf. So I'll just quickly go through. No, I won't.
That's fine. You can just, if you have to finish, you just finish your slides.
Yeah.
Maybe you have something very, very important to say. That's fine.
Yeah. Basically, you can find my slides, and there are a couple of config examples there, so you can just look at them at home.
Okay. Questions again. Thank you so much, Mr. Aleksi. Yeah.